exponent quiz tomorrow, just like this one. Those of you who got a 14, actually I'll say 12 to 14. If you got a 12 to 14, you do not have to take it again, although you can. Everybody else is going to take it again. Now, if you can get another 14, it's to your benefit to take it, but you don't have to. If you got below a 12, you're taking another quiz tomorrow. So let's do, you said we did the top one already? Let's do the bottom one. Let's do the bottom one. Unbelievable! Some of you missed this question. Let's talk about it again. What moves? Just the variable, because that is the only thing that has the exponent. That same thing, when you look at this problem, same thing. This has a negative exponent, so it is going to move. Does this move? No, it does not have a negative exponent. So there is nothing on the top, and you have all this stuff on the bottom. Now what is 2x, the quantity, cubed?
8x to the third.
8x to the third. So we end up with 1 over 16x to the 6. Count them up. 1, 2, 3, 1, 2, 3. That's a total of 6 x's. Couple of papers over in the margin. I saw this huge multiplication problem. No, no, no. What is special about 2, 8, and 16? They're all powers of 2. Please, I don't know what you mean. When you say divisible by 2, that's totally different than being a power of 2. Here, they have to be a power of 2. So we got 2 cubed, we got 2 cubed to the 4th, and we have 2 to the 4th cubed. Right? So we have 2 cubed. What's this? 2 cubed 4 times. So 2 cubed, 2 cubed, 2 cubed, 2 cubed. How many 2's is that? 2 to the 12. 2 to the 4th, 2 to the 4th, 2 to the 4th, that's 2 to the 12. Well, those cancel, so the answer to the problem is just 8. Cancel 14 into 7 because they have exponents attached. But what you can do is think about, okay, 14 cubed. That would be 2 times 7 times 2 times 7 times 2 times 7. And of course 7 to the 4th is 7, 7, 7, 7. Now, since you've got it all split up into its factors, you can start canceling. So on the top we have 8, and on the bottom we have 7. So there's our answer. 3/4 to the negative third. That whole fraction has a negative exponent, right? So the whole fraction is going to turn over. So we have 4/3 to the third, which is 64 to over 27. And finally, we have 100 divided by x to the 6 to the negative 1/2. Let's take care of the negative first, right? What's that negative going to do? It's on the whole fraction, so it's going to flip it over. What does a 1/2 exponent mean? Square root. Denominator's 10. Square root of x to the 6th means what times itself gives you x to the 6th? X to the 3rd times x to the 3rd. Yeah. So there's your answer. Okay? Now we got a couple of things to look at today, and then I want to get some homework questions taken care of. But first, I want you to consider a couple of problems. Do you remember yesterday and the day before when we built equations of exponentials and we came out with answers like this? I'm making this up, but that kind of thing. What's the significance of the 4? We kind of talked about that yesterday. That's your A value. What's the significance of the A value? Where does it come from? Bailey? It's the y-intercept. So if you let x be 0, your y value would be 4. So another way of thinking about that is that if x is 0, the value's 4. So if we think of this maybe as time, maybe our equation that has to do with the population that's growing over time, what would that 4 represent? The initial population, the beginning at time 0. So this is often referred to as the initial value. It is the starting point. Now, what does this tell me? How much it grows each time. So sometimes we have growth, sometimes we have decay. Which would this be? Would this be a growth or a decay? A growth, because why? It's bigger than 1. And the amount that it's bigger than 1 tells you what kind of growth you have. So how much bigger than 1 is this? 0.5, 50%. So this represents a 50% growth rate. As opposed to having something like this, the initial value is 3. So whatever we're measuring here or counting, we're starting with 3 of them. But what does this tell me?
95%.
This population is decreasing by how much?
5%.
5%. This is a 5% decay. The difference that you are from 1, remember 1 is the key. If you're more than 1, your growth. If you're less than 1, your decay. The amount that you're more than 1 is your growth. The amount that you're less than 1 is your decay. So if you had a population and you were told the population is growing 12% per year, and it starts at 1,000, you could write the equation. The initial value is 1,000, and you're growing at 12% a year. So what would that equation look like? Y equals 1,000, 1.12 to the teeth or to the x, whatever variable you want to use. If you are growing 12%, then your base here is 1 plus 12%. 1 is the key. Let's say that again. If your growth, you're more than 1. If your decay, you are less than 1. The amount that you're more than 1 is your growth. The amount that you're less than 1 is your decay. So if we had a population that was 80 to start with, and it was decreasing or decaying 10% per year, what would that equation look like? Y equals 80 times 0.9 to the x. Never ever do we use that actual percentage because 1 is the starting point. So you're either 1 plus that amount if you're growth, or you're 1 minus that amount if you are decay. Right? I've said that like 40 times. Everybody got it? So 1 plus growth, 1 minus decay. That's how you get this number right here. Okay. All right, now it's time to do do one more example. Would you turn to page 296? And if you look at problem 22, it says what you've seen before. Find the formula or the equation for the exponential function. Well, we've done that before. Y equals AB to the x, right? We've done this 2 days in a row. This time it's going to be a little different because we're going to need a calculator. How do you want to start? They gave you these 2 points and said write the equation of the exponential. The y-intercept is 3. So if you want to start by just plugging in 3, you can, right? Mathematically, it says 3 equals a times b to the 0th, but since that's 1, a is 3. So we have 3b to the x. Now what do?
Plug the other one in.
Plug the other one in, so 1.49 equals 3 times b to the 4th. Get your calculator out. How do I start solving that?
Divide by 3.
Divide by 3. So 1.49, 1.49 divided by 3. Oh, I got some decimal that I really don't want to round off, so I'm just going to leave it like this for the time being, because I don't want to round that off. It's on my calculator. It's just going to sit there for a minute. Now what do I have to do? Take the 4th root of both sides. Now, I've got a couple of options when I put this in my calculator. My favorite option, because it's just easier for me, is I don't have an actual button that says 4th root. I can get to the 4th root in my math menu, but for me, I prefer to think about that as being raised to the 1/4 power. Isn't a fractional exponent a radical? So I'm just going to take the number on my calculator, this decimal, and I'm going to raise it to the 0.25 power, 1/4 power. And I come out with b equal to 0.839, about. I have to round it off. Did you get that? So I write down my answer then, y equals 3 times 0.839 to the x. And then if the question says, does this describe growth or decay? Well, you can tell from your picture this describes decay. What is the percentage of decay? 0.161, so about 16.1%, if I subtracted right in my head. Everybody okay with that? All right, just for fun, I want to show you where that is. If you go to your math menu, just press your math button. If you go, for me it's number 5, I don't know if it's number 5 for everybody, but you see there's a button that's X root. That's how you can do a 4th root if you want to do that, okay? I never use that button personally, but yeah. All right, we have one more topic to look at, and then we'll look at your homework questions, then we'll do some word problems. But what we need to do now is number 24. Notice the directions. Find the equation of the logistic function. Now, for this one, this was an exponential, so we use this as our format, right?
Thank you.
Anytime it says exponential, we're going to use this as our kind of starting point. If it's logistic, we're going to use this. Now there are other forms you can use, but I think for our purposes this will be the easiest one. So this is the form we're going to use when it says logistic. Notice, in the exponential, how many variables did we actually have to figure out? In order to do this, we needed to find A and B, right? How many points were we given every time? 2. If I need to find 2 variables, I need to be given 2 points. How many variables do I have here? Oh boy, that means I'm going to have more information given to me. I need more information. So let's see what they gave me in problem 24. They said the initial value is 12. Now, stop right there. What does that mean? Over here, Laskowski told us, the initial value corresponds to what? The y-intercept. So this is like telling me the point 0, 12. The initial value is the y-intercept. Then it says we have a limit to growth that's 60. Okay, now wait a minute. We talked about that yesterday or the day before. Anybody remember that, or can you find it in your notes? What's going on with that, Trevor?
Isn't it
It's the horizontal asymptote. So if I were going to graph this, there'd be the top asymptote would be up here at 60. Anybody remember where that shows up in the equation? Where? That's A. That's A automatically. That's A. As long as this is a 1, which it's going to be every time you write your equations because you're using this format, that's your limit to growth. So already we know 60 over 1 plus BC to the x. And then what else did they tell me? I need one more thing. It passes through 1, 24. So the very first thing I'm going to do is stick that 60 in as my limit to growth. So that's done. Now I have these 2 points left. Which one do you think I'm going to start with? 0. I'm going to start with that one, just like I always do. So I'm going to put 0 in for x and 12 in for y. So 12 equals 60 over 1 plus bc to the 0. Now this is going to take a little more work than the other ones did. What's c to the 0? 1. So 12 equals 60 over 1 plus b?
Yep.
Now what?
Maybe time to decide.
Multiply this over to here, so 12 plus 12b equals 60. So 12b equals 48, and b equals 4. So now my equation is y equals 60 over 1 plus 4 c to the x. What do you think I'm going to do now? Plug in the other point. So 24 for y and 1 for x. Multiply this over here, so 24 plus 96c equals 60. 96c equals, what is that? 36. And 3696 does reduce.
3/8.
Thank you. So final answer, after all that, y equals 60 over 1 plus 4 times 3/8 to the x. All right, let's try 26 on your own. 26 is exactly the same thing. See if you can figure that out. You may need a calculator on this one. Here, everything worked out great, but you may need a calculator to do 26. This is your setup right here, okay?
296.
Take a minute, see if you can get that worked out.
Initial height is 5. The one that's a growth is 30. And it passes through 315. Put your A in already? What'd you put in? 30, and you were right. Your limit to growth goes right up there, so that's perfect. What did you do with the initial height? You recognize that that's what point? That's the y-intercept, so it's 0, 5. Hopefully you put that in. Did you get B as 5? Yeah.
Well, so far this is working out pretty nicely. So your equation so far is 30 over 1 plus 5c to the x. Everybody up to this point okay? Well, what did you do next then? Took that equation, plugged in 15. And this is 3. Is that what you got? What do I do with that? I cube root it. So you can either go into your math menu and you have a cube root button in your math menu,
4, you know what I'm going to do? I'm going to take 1/5 and raise it to the 1/3 power. That's just easier for me. You have a cube root button. If you go to math, it's one in the list. And what did your C turn out to be?
585.
About 1,585. So your final equation should have been that. Job? Yep, 1/5 to the 1/3. Cube root is 1/3 power. But you can use the cube root button if you prefer. Okie dokie smokies. All right, let's take a look at our homework. Last couple nights' homework before we jump into some word problems, because that's what's next. So who had an issue with one of the homework problems? Great.
Number 35 from last night.
35.
I just want to know because you wrote less than
9 to the x is less than 4 to the x. And it says solve graphically. So let's go into our calculators. First of all, let's stop a minute and think. What's 9 to the x going to look like? Just show me with your finger, general shape. What's 9 to the x going to look like? It's going to look like this, right? What's 4 to the x going to look like? Same sort of thing, right? They'll be different because one's a 9 and one's a 4, but the general shape is going to be the same. So how does that help me with my window? I'm getting ready to graph this. How should I have my window set up to accommodate what I know is going to look like that? Maybe my x's, maybe negative 10 to 10 is fine. What about my y's though? We know it's not going to be down here, right? So why don't we go ahead and let's just say negative 1 for safety. What do we know about 9 to a power and 4 to a power though? Those are going to get very, very big, aren't they?
Big.
So y max, let's make it a very, very big number. I just put in a whole bunch of zeros. I don't know what that number is. I think it's 10 million. Okay, now I'm going to graph 9 raised to the x power and 4 raised to the x power. I'm going to graph them. Now, I'm going to have to make some adjustments. Because what I got was this and this. What am I looking for? If I'm going to solve that, what am I looking for?
44.
I got to see where they cross each other, right? And I'm not seeing that. So I'm going to go back. And I'm going to change my y max to 100. I got to make it smaller. Okay, now I see a picture that looks like this. This is what I need to see, right? I need to see where they cross. So I'm going to make that window even smaller. Now I'm seeing this. So I'm going to make it even smaller. I'm going to quit talking now and just work. Because I need to see where those things cross each other. Now I'm getting close. it till you see it. All right, I got a great picture now. My window on the x's is -2 to 2, and on the y's it's -1 to 2. And I have a beautiful picture where I see them crossing. It looks like they might cross back here too. I haven't found that point yet. I'm gonna have to look at that a little more closely. Okay, the bottom one is 4 to the x, and this one is 9 to the x. Okay, how do I find where they cross each other? I have to do my intercept, so I'm working on that right now. What'd you come up with? 1. They intersect at 1. Does that make sense? At 0, 1? Does that make sense? What happens if you put a 0 in that for that x?
E1.
What happens if you put a 0 in for that x?
E1.
So that sort of makes sense, doesn't it? So now how do we answer the question? We know they intersect here. We want to know where the 9 curve is less than the 4 curve. Okay? So the 9 is less than the 4. According to what I labeled, but I'm not sure I labeled right. I need to watch that graph again because I want to make sure. Okay, which one did I put in first? Oh, I put in the 9 first. I had a network. So this is the 4 to the x, and this is the 9 to the x. Okay, that makes more sense. So I want the 9 to be less than the 4. So that happens right here in this part of the picture. So x has to be less than 0. So your answer is all the x is less than 0. So Grace, long, drawn out problem solving here, but we had to figure out from the picture where the 9 curve was lower than the 4 curve. And then we had to figure out where they were equal so we knew where to cut it off. Yeah. Okay. All right. Who else had a question? That was a easy. Who else had a question? That one was problem. Vincent.
51.
51. When would the population of Austin surpass 800,000 people? Okay, well, right now, What do we know about the population of Austin? We know that in 1990, it was 465,622. And in 2000, it was 656,562. And we want to know when it's going to be more than 800,000. Well, Vincent, did you have any idea how to start this?
Well, I was thinking of using. Not really.
Well, let's think about it for a minute.
Those could be points.
These are points. And could we think of this as our initial value, since it's the starting point of when I was measuring the population? So if I'm going to build my equation, my A value could be that guy right there. So y equals 465,622 b to the x. Now be careful. I made this 0. I made that the initial point, which means this isn't going to be 2,000 anymore. This is going to have to become 10. So now I have another point. Would you agree? So I have another point I'm going to plug in here. So 656,562 equals 465,622 b to the 10th. Now it's messy as heck, but word problems always are. So how do we go about solving that? We're going to divide. Let's not round that number off. It's not going to be pretty, but we do need to divide it. So let's go ahead and get it divided on our calculator. So I'm going to have 656,562 over 465,622 equal b to the 10. All right, so I'm going to go ahead and do that division. And it's some decimal. Now, what do I need to do with that decimal? I need to do what to it? I need to take the 10th root, which you know what I'm going to do. I'm not going to take the 10th root. I'm going to raise it to the 1/10th power. So the decimal on my calculator, I did this division. I have the decimal on my calculator. I'm just going to hit raise to the 0.1. And it gives me about 1.035. So my equation is y equals 465,622 times 1.035 to the x. Now, when is it going to be 80,000 is the question. What do I do with that 80,000? Plug it in where? Whoa. This is awesome. Because here are your choices now. So 80,000 equals 465,622 times 1.035 to the x. Now, here are your choices. Depending on how much time you have, you can trial and error it. So you can just say, okay, I'm going to put in 10. Crank it out. If it's more than 80,000, go down to 9. If it's not quite 80,000, go up higher. You can do that. Or you can do what? Use logarithms. Exactly. So you would divide both sides. You can't do anything until you divide. But you divide both sides. Oh, shooty tooty. And then take the logarithm of both sides. All right, we'll finish this tomorrow because that's exciting stuff. All right, have a good day. Oh, step on the poster. What are we drinking today there, Emma?